Hi, everybody, and a very warm welcome. Try that again. Hi, everyone, and a very warm welcome to this live webinar that we are using to launch the Zindi Weekend's Road Segment Identification Hackathon. The event, the hackathon is in fact live right now on Zindi, but as we have done for several previous Zindi Weekends events, we thought we would launch it this first Friday of September with a bit of a chat with somebody who's been closely involved with a similar problem and with the conceptualization of this particular challenge, and also share a bit of a starter notebook so that you can get going and get to know a bit more about how the competition will work and how you might get started if you are unsure. So with that, the challenge is focusing on SDG 9, which is infrastructure, innovation, and industrialization. SDG 9 is particularly relevant to Africa, of course, as many of the SDGs are. We have something like a quarter of all roads in Africa are paved, as opposed to something like half in the rest of the world. So there's obviously a huge development challenge, and the development of a good road network leads to many downstream industrial benefits and economic benefits for a country. So roads and road networks are obviously very important, and so we hope we can contribute to that particular challenge this weekend. With me today, I have Dr. Mark Pina from SEON. He's a researcher at SEON. Mark has a PhD in electrical engineering, where he worked on classification machine learning challenge. Mark helped us develop the concept for this particular challenge as he works on road challenges for SEON. Very warm welcome to you, Mark.
Thanks. Great to be here.
Great to have you. Before we dive into what we're talking about here, would you introduce yourself to the listeners and the watchers? Tell me a bit more about who you are, who SEON is, and the work that you do.
Right. Well, hi, everybody. My name's Mark Pina. I have a bit of a varied background. I spent about 15 years working for a research organization called the Council for Scientific and Industrial Research in Pretoria, South Africa. Initially doing dating experiments. I did a master's in dating, specifically a radiometric technique. I then got an interest for signal processing, and that led me to enrolling in electrical engineering, which was my introduction to machine learning. That evolved into that. For the last 2.5 years, I've been working for SEON in the data science team. And specifically SEON, it stands for the South African Environmental Observation Network, is an organization under a flagship called the National Research Foundation in South Africa, and it's mandated to collate and coordinate environmental systems. There's a bunch of research nodes in SEON aimed or geared towards this objective, and they look at both terrestrial and oceanographic research. And then there's a data node called Ulwazi, which I fall in. Within Ulwazi, there's 4 teams. There's a data curation, a systems development team, a infrastructure team, and a data science team. I'm part of the data science team. We're a small group of about 6 people. We're closely knit. We work well together. And that's basically my background and my background in SEON.
Brilliant, thanks, Mark. And I'm happy to say this isn't the first time we've worked with SEON. We've had some things to do with SEON previously, and with the Ulwazi node, particularly working on air quality data with you. So it's nice to be continuing a relationship with you guys. So can you tell us more specifically about your work on the South African road network, and perhaps a little bit about how a road classification challenge or a road segment classification challenge would fit into that work?
Right. So about a year or 2 ago, we started a project, and we're managing it, called the South African Bioenergy Atlas, in which version 2 specifically, in which the updates were basically a logistics model to include transport parameters and costing and those sort of things. And my interest in the kind of road classification came about initially with the traditional shortest path type stuff, trying to get feedstocks for bioenergy to a road side. And then eventually we had to use the road network to graph it up and find ideal locations for bioenergy processing facilities and so on. And we looked at two road data sets, freely available road data sets, that is OpenStreetMaps, that's the obvious one. And then the South African National Road Dataset, which comes from the National Geospatial Information Platform. Both of them had the same or similar problems, namely that road segments were missing in certain places, even in national roads, meaning graph creation was difficult. So it required manual intervention and a lot of bug fixing before we could create a coherent graph. And secondly, there were a lot of missing roads, particularly in the rural areas. And that's where the idea for this challenge, I guess, sprung. It was how can we get a solution to not have to manually intervene and spend a lot of time just dealing with bugs in road networks.
Mm-hmm. Great. And so, I mean, what are we looking at when we're looking at the data set now? What does the data set actually look like that the competitors will be working with?
Right. So this data set is a small classification experiment, and it also comes, the imagery also comes from the NGI, the National Geospatial Information Platform.
Mm-hmm.
It's high resolution imagery, freely available for South Africa at 25 centimeters. It's aerial photography. There's actually 3 layers that the NGI created. In fact, there's more, but the 3 dominant ones are mosaic at 50 centimeters for the period 2010 to about 2016. And then 2 higher resolution 25 centimeter layers for 2017 and 2018 that cover most of the country, but not all of it yet. And it's that layer that is used in this competition, various image segments. The actual classes, in collaboration with you guys, with Zindi, we sat down and had a few workshops and said, let's create things that look like roads and rails and boundaries and things like that, which were then later aligned to fit the features of the images themselves. And that's the actual experiment to see if you can identify roads using this imagery. We would have liked time series, obviously, but the highest resolution satellite stuff is only 10 meters, perhaps 5 centimeters if you go for spot or something. And that's a little too coarse for road identification.
Okay. So, I mean, if we think about perhaps extrapolating this beyond South Africa to the rest of Africa, is there this sort of data available, and do you see this kind of approach working for other parts of Africa as well?
I hope so. Certainly, the data in South Africa is slightly better for many parts in South Africa, for a start, not all of them, but for many parts. And the South African data set alone is quite large if you download the whole thing. And if there was a machine learning kind of solution, you could automate a specific area end-to-end solution. You wouldn't have to download an entire road segment. You could just automate the whole process. And even if you don't do that, you could at least use it to fix up existing roads and road segments and missing roads and so on and so forth. And yeah, it would be very important for Africa in the application space. An immediate example that comes to mind might be a COVID vaccine rollout, for instance. You could do that in little bits and find optimal, especially with cold-vac. You could find a nice solution using a good coherent road network if you wish.
Yeah, so I guess the sky's the limit really in terms of the impact that you could have by having a clear picture of what the road network looks like.
Absolutely. Without that, you're just spending a lot of time fixing a road, and your confidence in the actual network that you're busy analyzing is very slim. In the bioenergy atlas, we certainly didn't have a full graph, for instance. So, the analysis is suboptimal.
Yeah. Okay. So actually getting a tool like this, or at least getting the outcomes of a tool like this into the hands of planners, government planners, anything involving logistics is really going to have quite an impact.
Yes. And certainly in discussions I've had with you guys and others, there's a big need for this and a nice requirement from lots of people.
Brilliant. Okay, so I think that's all I wanted to talk about, and I think after the competition's done, we'll have to have a discussion further about how the solutions are going to be shared effectively, and I hope Seon would be willing to be a part of that, and hopefully trying to make the solution more widely applicable as well.
Yes, yeah, no, definitely. We, just as a last point, we currently, since Seon's mandate is to make data freely available for the benefit of others, we do have an open data platform that releases the metadata with the data, so the authors of the algorithms and the imagery and all of that, could go through that portal as well. But we can certainly have that discussion later.
I think that would be great to see the outcomes being made available for public good and for everybody's use.
Absolutely.
Great. Okay, thanks, Mark. I'm going to leave it there. It's been really great to talk to you, and thank you for taking time on Friday afternoon to share a bit of your expertise. I'm sure that the attendees and participants really appreciate it.
Pleasure. Thank you very much.
Thanks. Okay, so thank you very much to Mark. We will now ask a data scientist who helped us in the preparation of the data, Mr. Ted Mutomi. We'll ask Ted to join and take us through the work that he's done and demonstrate his starter notebook. A starter notebook that will also be available to you when you're looking to take part in the challenge. Hi, Ted, are you there?
Hi, Paul.
Hi, Ted. Welcome. Welcome to the webinar. Are you ready to share your starter notebook?
Yes, I'm ready.
Okay, great. So you should be able to share your screen. There's an option down at the bottom. There we go. I can see your screen. I'm going to leave the stream. I'm going to hand over to you. You have as much time as you need to take us through.
This is not going to take a lot of time.
Okay, great.
So for this starter notebook, you just need Fast AI. So this is sort of like it's the same as Keras, but Keras works. Keras is built with TensorFlow, whereas Fast AI is built on top of PyTorch, but it makes running deep learning models very easy. So you just need to install the libraries needed, and then to load the data. So to load the data, you can have the data installed or uploaded to your drive, and then after uploading to the drive, you can mount your Colab. And then to mount your Colab, after mounting your Colab, you can either read individual files from there, or read the entire folder of the images. But it would be advisable if you uploaded it to drive as a zip file, and then unzip the file from Colab. That would be easier. Now for this, when reading the path here is the path of where the data is, and then the folder here is the folder containing the images. To split by rand is the percentage of the validation set that you'd like. So this 15% is not going to be used in training. And then after loading the images, you can add this to the data bunch, the test sets to the same data bunch, and then create a model. To create the model, we're going to use a simple CNN neural network, and we're going to train on a pre-trained model, the ResNet34. This is a predefined neural network architecture for computer vision, and the metric being ROC AUC. And then after learning. Now you can fit the data, and then find the best metric for this, and then after that make predictions. This is the line of code that you'll need to make predictions, and then make a submission file. The submission file you make from this, it can be uploaded directly to Zindi to get a score.
Oops, I was on mute. Thanks very much, Ted. Is there anything else that you'd like to share, or do you think that's good enough? Ted, are you there?
Yes, I'm still here.
Okay, great. Are we? Is there anything else you'd like to share, or is that all you wanted to take people through?
That's all I'd like to take people through.
Okay, great. Are there any questions then? While we have Ted on the call, this is a great time for you to ask questions. We are just verifying the notebook, and then that will be uploaded to the competition platform under the data tab. So meanwhile, you can get started on the competition, downloading the data, etc. We will we'll upload the starter notebook as soon as possible. If there are any questions, this is your time to ask them. I'm happy to leave the stream open for a few more minutes so that if there are any questions or queries, we can address them. Okay, I see I have a question about pseudo-labeling. I'm going to add my colleague Rose, who is a data scientist at Zindi. Rose, would you be able to answer that question?
Sure, Paul. Thank you, Paul. What do you mean by pseudo-labeling?
Okay, we'll have to wait for an answer there.
Yeah.
Aninda,
I have a question.
There we go. Yeah.
I have a question for Ted. Like, what challenges did you face? Like, for a participant, we would like to know the challenges you faced while you're preparing the data set.
The main challenge was in finding roads from a huge segment of data. So for some of the roads, most of the roads are not tarmac roads, but the data we used was 25 centimeter resolution data, that's among the best that you can get. So the main challenges were, first of all, detecting places with finding the places with roads, and the second one was separating roads from rivers and from crop boundaries, since most of the rivers and tributaries, when they are dry, they look the same as roads that are not tarmacked.
Thank you, Ted. I can see a question. Can we predict on test data and use that to train again a separate model? No, that is not allowed. We want you to train on the training data set provided, and that is able to predict on new roads given.
Cool. Thank you very much, Rose. And thanks, Ted, for sharing a little bit about the data preparation There's always a huge amount of work that goes on behind the scenes in preparing data for a challenge on Zindi. So Ted and Rose, they're the real superheroes here. I just get to be the face of these things, but these guys work really hard in the back rooms, making sure the challenges are ready for you. Thanks very much for the clarification. I don't see any other questions. I will leave the stream open for a few minutes, but I think we are otherwise we're ready to let everybody get on with the challenge. So I will leave it there. I'd like to say a big thank you to Dr. Pina, thank you to Rose, thank you to Ted for being here, for helping us in launching this challenge. I'd like to wish you all very good luck this weekend. The competition is open now. It will close Sunday at midnight GMT. This is, as I said, a weekend hackathon. The starter notebook, we will upload it as soon as we can. We're just gonna do some verification on our end to make sure that it's working in working order and all of that. So that'll be uploaded in the next, I think, next half an hour at the absolute outside. I guess all that's left for me is to say a very good luck to all of you. I hope you enjoy the challenge. If you have any other questions, I'll leave the stream open for a few minutes. Otherwise, you can feel free to ask your questions on the discussion forum, and we will get back to you. Great. Thank you all very much. Cheers. Hi, Sahar. The event is open. The hackathon is open, so you can just join the hackathon via the link in the YouTube description, and as long as you've signed up for the hackathon, you will be able to download the data. It is currently available.